Hi guys, this is your channel Stat and Math Tutorial in a new video. Today I'm gonna show you how to use the root test to determine if a series converges or diverges. So let's start with the term first. So the root test, let an be a series with positive terms, and suppose that the limit of the n root of an equals L as n goes to infinity. So if L is less than 1, the series converges, and if L greater than 1, the series diverges. However, if the test is if L equals to 1, the test is inconclusive. So let's do a few examples here so you can see how we can use the root test to answer such question. So the first example here, the series from n equals 1 to positive infinity of 4n plus 3 over 3n minus 5 the whole thing to n. So let's do the root test here and see what we can talk about this series. So now you do the n root of 4n plus 3 divided by 3n minus 5, so whole thing to the end, and that's supposed to be n, not 3. So the n root. Okay, so now the power n and the n root will cancel each other, and I end up with 4n plus 3 over 3n minus 5. So let's find out the limit of these as n goes to infinity. So 4n plus 3 over 3n minus 5 as n goes to infinity. So 4n plus 3 goes to positive infinity. Same thing for 3 minus 5, it goes to positive infinity. So it's undefined. So now let's divide everything by n and try again. So limit of 4n divided by n plus 3 divided by n, the whole thing over 3n divided by n minus 5 divided by n as n goes to infinity, and simplify. Need more room here. So if we simplify, it's gonna be the limit here as n goes to infinity. So 4n over n is 4 plus 3 over n divided by 3n divided by n is just 3 minus 5 over n. Now 3 over n goes to 0 as n goes to a positive infinity. Same thing with negative 5 over n goes to 0. So the limit is 4/3. So 4/3, it's greater than 1. So we conclude that the series diverges. By the root test. So now let's look at second example here. So second example is the series, it's from n equals 1 to positive infinity, 1 over 1 plus 3n, the whole thing to n. So same thing, we do the root test. So n root of 1 over 1 plus 3n, the whole thing to the power n. Power and the root cancel each other, so I end up with 1 over 1 plus 3n. So let's find the limit of this function as n goes to infinity. 1 plus 3n as n goes to infinity. So the bottom goes to positive infinity, and 1 over like a positive number, it's almost 0. So the limit here is 0, and 0 of course is less than 1. Therefore the series converges by the root test. Okay, now let's look at the last question, which the series will diverge. So the last question, we have a series from n equals 1 to positive infinity, n square over 2n, 2 to the n, sorry. And same thing, we're gonna use the root test. So n root of n square over 2 to the n. Simplify, so it's gonna be the top one alone, so n square, the n root of n square over n root of 2 to the n. Using the power rule here, it's the n root of n and the whole thing square, divide by, so the n root of 2 to the n is just 2. Now let's find out the limit. The limit of that as n goes to infinity. So the n root of n square over 2. So here is the trick here. So this function here, as n goes to infinity, the function gets close to 1. So the y equals 1 is a horizontal asymptote of that function. And you can try like 100 to 1 over 100. That's the same thing as 100 root of 100. And it's gonna be approximately 1. You can try 1,000 to 1 over thousands. Same thing, that's the thousandth root of 1,000, and it's gonna be 1. As n get larger, it's get very close to 1. So here the top one, the limit of the top one is 1. So this guy here goes to 1. So the limit as n goes to infinity of the n root of n, the whole thing square over 2, is just 1/2. Because 1 square is just 1. And now, since 1/2 is less than 1, we conclude that the series converges. So 1/2 less than 1. Therefore, the series converges by the same test, by root test. I hope you like this video. Thanks for watching and see you next time.